Hello, you guys. I hope everybody had an awesome holiday. Okay, take a look at 5.7, solving inequalities. Whoops, I didn't want to do that. Okay, let's see. Sorry, let me grab my pointer. Okay, so there's some vocabulary that's really important, and I know we talked about this a little bit in class. So listen, an inequality means that something is not equal, okay? And there's, for example, things could be is less than or is greater than. Now we're going to see when we graph is less than or is greater than, we're going to use open dots like a bubble, okay? Completely open. You could see through them. Now, if I say is less than or equal to, then it's going to be a closed, filled in dot, okay? Because it could touch the number. It could be equal to. Or if I said is greater than or equal to, it's going to be a closed, filled in dot. Okay, take a look at example 1, letter A. This says A is greater than -6. Well, since it's greater than, but it's not equal to, we're going to do an open dot at -6, and we're going to shade all the numbers larger. So this just means all numbers greater than -6. If we look at B together, T is less than or equal to 4. See that or equal, that little underline? That means it's going to be a closed dot because it could touch the number 4. And then we're going to shade everything smaller, everything to the left. Okay, so we just did B, so make sure you fill this in. All numbers less than or equal to 4. And because of the or equal, that's why it was a shaded in closed dot. Take a look at letter C. X is greater than 0. Since it cannot be equal to, we're going to put that open dot at 0, and we're going to shade everything larger, everything to the right. So this is red, all numbers greater than 0. Take a look at D. Q is greater than or equal to -3 1/2. Now we knew that it was or equal to because it was shaded in, and it's everything greater, everything to the right. So it's greater than or equal to -3 1/2. Okay, take a look at number 1. Y is greater than or equal to 5. Well, because of the or equal part, it's a closed dot. So put a closed dot on 5 and shade everything to the right, everything larger. Take a look at 2. See how they try to trick you? They say 1 is greater than n. Well, I want you to write it with the n first, just like you would say it to me out loud. If I started at the n, I would have to say n is less than 1. So that's the way I want you to write it. And then, since it cannot be equal to, put that open bubble, that open dot at 1, and shade everything to the left, everything smaller. Okay, take a look at number 3. P is less than or equal to -2 1/2. Well, because of that underline, that or equal, it's a closed dot. So put a closed dot at -2 1/2, and then shade everything smaller, everything to the left. And then look at number 4. Z is greater than -1 1/2. Well, because it cannot be equal to, it's an open dot. So put an open dot at -1 1/2, and then shade everything to the right, everything larger. Okay, now we're going to solve them and then graph the solution. So take a look at A. M minus 3 is less than 8. So I wrote it over here. M minus 3 is less than 8. Then grab your red, add a line, change the sign. So we want to get rid of adding -3. Well, we're going to add a +3 on both sides to get rid of it. And so bring down your M. The -3 plus the +3 destroy each other. They cancel out. Bring the inequality straight down the wall. And then 8 plus 3 is 11. So this is red. M is less than 11. Well, because it cannot be equal to, we put an open dot at 11, and then it means all numbers smaller than 11. So shade everything to the left, everything smaller. Okay, take a look at B. X minus 9 is greater than or equal to -14. So I copied it over here. Grab your red, add a line, change the sign, and so now we want to destroy adding -9. Well, that means we have to add a +9 on both sides of the wall. Okay, so bring down the x, a -9 plus a +9 destroy each other. Bring down the inequality, And then negative 14 plus 9 is negative 5. So this is read, x is greater than or equal to negative 5. Well, because it could be equal to, it's a solid closed dot at negative 5, and then we shade everything greater, everything to the right. Okay, take a look at letter C. 6 plus A is greater than 13. So I wrote it over here. I want to get rid of the adding 6, so I'm going to subtract 6 on both sides of the wall. So 6 minus 6 destroy each other. Bring down the A, bring down the inequality, and 13 minus 6 gives us 7. So this is A is greater than 7. Well, since it cannot be equal to, put that open bubble at 7, and then shade everything greater, everything to the right. Okay, so we're going to solve the inequalities and then graph their solutions. So take a look at number 5. I wrote it over here. Y minus 7 is less than or equal to negative 2. So grab your red pen, add a line, and change the sign. So we need to get rid of adding negative 7. So we're going to add a positive 7 on both sides of the wall. So bring down the y. A negative 7 plus a positive 7 destroys each other. Bring down the inequality, and then negative 2 plus 7 gives us 5. So that is y is less than or equal to 5. So I want to see a solid closed dot on 5 because it could be equal to, and then shade everything less, everything smaller. Okay, take a look at number 7 here. 15 is greater than or equal to z plus 18. So now I want to get rid of the adding 18, so I'm going to subtract 18 on both sides of the wall, and that gives me 15 plus negative 18 is negative 3. Bring the inequality straight down the wall, bring the z straight down, and 18 minus 18, of course, destroys each other. That's 0. But now you don't want to graph it when the variable is the last thing you read. This says negative 3 is greater than or equal to z. So I want you to write it backwards. Okay, start at the z. You would read this to me as z is less than or equal to negative 3. So I wrote it right here. And now graph it like this. Since it could be equal to, put a solid closed dot at negative 3. And this means z, everything smaller than negative 3. So everything to the left. And shade that. Okay, take a look at number 6. I wrote it here. 4 is less than t minus 10. So grab your red pen, add a line, change the sign in front of the 10. So we have to destroy adding negative 10. That means we want to add a positive 10 on both sides of the wall. So 4 plus 10 gives us 14. Bring the inequality straight down. Bring the t straight down. And then negative 10 plus positive 10 destroys each other. Now don't graph 14 is less than t. Read it to me backwards, starting with the t. T is greater than 14. That's what I wrote here, and that's what I'm going to graph. Since it cannot be equal to 14, I'm going to put an open dot at 14, and then we're going to shade everything larger than 14. So shade everything to the right. Okay, take a look at number 8. 7.5 plus r is greater than 3. So I want to get rid of that adding 7.5. So I'm going to subtract 7.5 on both sides of the wall. Well, a positive 7.5 minus 7.5, of course, destroys each other. Bring the r down, bring the inequality down. And this you got to remember, okay, a positive 3 minus 7.5. Well, remember, the negatives are going to win that battle. So I'm going to put the 7.5 on the top, the 3 on the bottom, put a decimal, add the 0, and then subtract. So 5 minus 0 is 5, 7 minus 3 is 4. But remember, the negatives had more, so this is negative 4.5. So r is greater than negative 4.5. So it cannot be equal to, so I'm going to put an open bubble at negative 4.5, and then I'm going to shade everything greater, everything to the right.